So yesterday we talked about P and S waves, and we did this whole top chart pretty much together. And I'm pretty sure this class, we got to the similarities and differences on the bottom. But I do want to review that because that is where this all, like where today's lesson starts. So what was one of the major similarities we had between P and S waves? Who can remember from yesterday? If you don't remember from yesterday, flip back and review your chart about P and S waves on page 19. Yes, that is actually, I think the number one similarity is that they leave the earthquake, which is at the focus where the two plates hit each other. So they leave the earthquake at the exact same time. That I think is probably the most important similarity, is that the moment that earthquake happens, it releases a P and an S wave from the focus. They leave at the same time. I kind of relate this. I know yesterday I was talking about Ferraris and was that this class? How about a school bus and a regular car leaving your house to come to school? Yes, definitely the car goes faster than the school bus would get here, right? So P wave, what was again one of the most important differences about the P wave? Okay, so so first of all, they're fast, just like a car versus a school bus. And because they're fast, then which one's gonna get here first? The P wave, so it arrives first. So, and as you said, it can go through anything. And that is actually leads me to something that I think got a little confusing yesterday. When I say go through anything, that's solid, liquid, and gas. So the liquid that I'm talking about though, is I'm not talking about just water liquid. So I'm not just talking about oceans or lakes or ponds or whatever. I'm also including the liquid layers of the earth. So P waves can go through all of the layers. It doesn't matter what they're made out of. Whereas the S waves, they can only go through solids. So the S waves cannot travel through the liquid outer core or parts of the asthenosphere that have been melted. So that is a huge difference between P and S waves. And that is actually how scientists were able to discover that the outer core was liquid. They could track the S waves until they hit that outer core, and then they basically got stuck. The other major difference is they are slow, which makes them arrive second. So like I said, if they were a school bus and a car leaving your house at the same moment, so you get on the school bus and your brother drives to school because you pissed him off and he's not taking you to school anymore. So you both leave at the same moment. Whoever's driving the car will definitely get here way before whoever's on the school bus. And that's going to lead us to page 11 of your reference table. So if you could all turn to page 11 of your reference table. So on page 11, first of all, you can see it's titled Earthquake, P and S wave travel times. So we're going to be talking about how long it takes the P wave and the S waves to travel different distances. Just like I was saying, how long it takes you in the school bus versus your brother in a car to travel to school. So it's a very similar concept. Who here rides the school bus to get here? Angel, how long does it take you to get here in a school bus? Holy cow, that's awful. That is horrible. That's an extra. That is how long it takes me to drive to work from Eden. That's crazy. I feel bad for all of you that are on the school bus that long. So Angel, what's Angel's travel time to get here? 45 minutes. So travel time is just how long it takes you to get somewhere. Angel, when you get dropped off in a car, how long does it take you to get here? Oh my God. Oh, that's awful. I feel bad for you. And anyone else who's in a similar situation. That is horrible. You got to leave so early. Anyway, sorry, off topic, but travel time, again, just how long it takes to get from one place to the other is how long it takes you to travel. So it doesn't talk about what time you get here. So I didn't ask Angel, what time do you arrive at school? I don't want to know that yet. I said, how long does it take you to travel to school? So you do have to get pretty good at noticing the difference in those words. So how long does it take you to travel versus what time do you arrive? So you just got to get used to those different ways of talking. So here again, we have travel time. So this is the 45 minutes it takes Angel to travel to school. You can see that travel time on the y-axis is given in minutes. So we start down at the bottom at 0 minutes, and this graph goes all the way up to 24 minutes. Before we get going on this too much, I want to make sure you realize, so you see the lines go up. The dark bold lines are labeled every minute. So we start at 0, we go to 1 minute, 2 minutes, 3 minutes, 4 minutes, etc. But we need to talk about what are those little lines that are not labeled going up by 31, first of all. What do you mean? But 30, what's 30 minutes, 30 seconds? Yeah, so they're not 30 because then it would only be 1. It would go 0, 30, 1 minute. So what are these little lines? There's 2 of them. Then it would go 15, 30, 45, 1 minute. So they're 20s. So here, just to make sure you understand this, how many seconds are in a minute? 60 seconds in a minute. And they're, so here, and I actually think you guys should label at least one set of these so you don't forget. Right here, this first line would be 20. And then 40, and then it starts over again at 60. So I know you're gonna, and that's why I only say one set, because it does kind of get cramped in there. So I labeled the first line 20, and then 40, and then I didn't need to label anything else. Just so you don't forget what those are going up by, or maybe put a little note here. Goes up by 20 seconds. However you want to do that so that you remember, because that is going to be the first thing you're going to forget when you're doing these on your own is what are the lines going up by. Now, the y-axis is labeled epicenter distance. So remember from our notes yesterday, what is an epicenter? What do you mean, the middle of what?
The one that's above ground or the one
Yeah,
under ground?
so one that's above ground. So it's basically where the earthquake is happening, but just on the ground. So it's basically saying where it happened, what city or what latitude and longitude the earthquake happened at. And it's saying how far away is that epicenter, so where the earthquake happened, to where it's traveling to. So if you were standing here, we might be 10 miles from the epicenter. It just means how far away you are from the epicenter. Or in terms of the whole school bus situation, it's how far away is your house from school. So your house would be the epicenter, and then distance to the epicenter would be how far it is to get here. However, I just said 10 miles. Notice this little parentheses here. It says times 10 to the third. What does that mean? Careful. So it's 1. If I was here, 1 times 10 to the third. Yes, that means, what does the times 10 to the third tell you to do? It does not necessarily mean add 3 zeros. What's it tell you to do? Times it by 10 to the third, when 10 to the third is 1,000. So this is really 1 times 1,000. What the 10 to the third is doing, it's not just flat out telling you to add 3 zeros, which we will do to some of these numbers. It's telling you to move the decimal over 3 spots is what it's doing. So if you have 1 and you move the decimal over 3 spots, it's 1, 2, 3. Yes, in this case, it was adding 3 zeros, but careful, if it was 0.5 times 10 to the third, then we're taking the 0.5 and going 1, 2, 3. So in that case, you would have only added 2. So be careful with just thinking about it as adding adding zeros. So what this is saying is this 1 right here is not 1 kilometer. How many kilometers is this? 1,000. I'm going to go ahead and add that at least to, like I said, at least to a couple of them so I don't forget. So this is 1,000 kilometers away, 2,000 kilometers, 3,000 kilometers away. Again, so now those big bold lines are easy to see, but what are the little lines going up by? Okay, so 200. How did you figure this out? You could have done math. I do process of elimination. So I try, are they going up by 100s? 1, 2, 3, 4, 5, no way. So then I need to go up by something bigger. Again, I'm going to label one set of those, 200, 400, 600, 800. I recommend you either label them or give yourself a note that say they go up by 200 kilometers. Whatever you got to do so that you don't ask me the same exact question in a few minutes. Not doing any of this. You didn't label any. Okay. So then what do we have here? It's just a graph. It's a graph with 2 lines. You guys know how to read graphs, and you know how to read graphs that have 2 lines. The 2 lines, they're clearly labeled. So this one is the P wave, and this one is the S wave. So, or if we were talking about Angel's ride to school, this would be in the car, and this one would be in the school bus. So you notice the lines don't really match up, but they kind of behave the same way. So that also, again, makes sense. So if we were just to read this like a normal graph, which is actually, if you're all on page 21 of your packet again, is what I actually just was having you do is read this. Make sure you know how to read this graph. Starts with how long it takes the P and the S waves to travel the distances listed below. Can you do that? So the first one's going to be 7,000. So I want to know how long it takes both the P wave, then the S wave to travel 7,000 kilometers. What do I need to do that? How do I figure that out from this graph? How long will it take the P wave to travel 7,000 kilometers? You want to walk me through it? That's it. So you go to the 7,000, which remember is 7. That's 7,000. You go up till you get to the bold P line, and then you go over. So take a minute or take a second, I guess, to do that, and let me know what you get. So everybody give that one a whirl. How long does it take the P wave to go 7,000 kilometers? How many minutes and how many seconds? So everybody should have an answer. And no, we're on the first one on page 21, 7,000. So what do you guys get? 10 minutes and 20 seconds. You all agree? Do you? For real? I'm seeing a slight problem with that answer. Would it be 22 seconds? So you do have to see that it is a tiny bit above that 20 line. And you say, okay, is it just a couple seconds? Keep in mind that that next line up is going to be 10 minutes and 40 seconds. So no, I agree that we're not halfway between the 2 lines, but we're definitely not right on that line. So let's go with 10 minutes and 25 seconds. You guys with your 21 or 22 is fine as well. Now you do the same thing for the S wave. What are you thinking for the S wave for 7,000 kilometers? $19 minutes, pretty close. Again, you probably could have gone with 18.
49 seconds.
Ooh, not 49.
Not 49.
It's way closer than 49, maybe. Yeah. 19 again, it's fine. But be careful if you were gonna go with the estimating there with the 40 or the 59 seconds. Is it 19 minutes and 59 seconds? No, it would have been 18 minutes and 59 seconds. But like I said, the 19 is fine. And the 20 was probably okay for that one as well. Go ahead and go up to, we'll do 1, 2, 3 more. I want you to do those ones on your own. You're not sure what you're doing, call me over and we'll make sure you get this part. Did I give you guys these blown up reference tables? I did not. I'm doing out one of these right now. I'll show you why this might be helpful. It is, when you hold it in half, it's the size of a regulation. All right, so bigger you notice, it might help you do your estimating. Because it's, what? Yes, go right ahead. Yeah, that's probably, I'll do that for the rest of my class, is just give them these first. So they're easier to label. So Carly mentioned these are huge. And like I said to Carly, when you fold them in half, they're the size of a regular sheet of paper. So if you fold these in half, you can probably just stick them right in your reference table. You want to staple them on, well, stapling them probably wouldn't be a good idea because then you can't use them well. The reason I thought these might be helpful is it helps you estimate a little bit better because you have a little bit more room. Now I'm not gonna be able to fit them all on here. So let's go through these. The first one I asked you to do now on your own. So guys, don't bother doing extra. I'm not gonna have you do extra. So if you just thought you're getting ahead on something, you're not. So like I said, the first one was 3,900. Guys, where is 3,900? It is. So here's 3,200, 400, 600, 800, and there's 4,000. So 3,900, you legit have to go to where that would be, which is halfway between the 800 and the 4,000. So you go up. Now, one way you could do this would be to follow either one of those actual lines up. So I'm going to follow the 4,000 up. 3,800 is halfway between the box before it. So it's halfway in there. And I can see it doesn't hit right on 7 minutes. It is a tad bit before 7 minutes. If you put 7 minutes, are you going to be wrong? No, you would get full credit for this question. The reason why I'm being picky like this is because as we build on what we're doing today and move into what we do tomorrow, they kind of build on each other. And if you're a little bit off on one question, the second part of it's going to be even more off. And then the third part of it will be even more off. And in the end, you might get an answer that's very, very different than what it should be because you just did estimating wrong in the first step. What'd you guys get for the S wave then for 3,900? Anybody? Yep. So again, we follow. So right about here, I agree. 1230 looks perfect because it's not right on the 1220 or on the 1240. And how about for 2000?
4 0 for P-Wave and 720 for
Okay, so Jake knows how to do this. How about anybody else? 6,100 or 1,600. Yep. I also did. And then the S wave. What'd you say? 6 minutes. Oh, 6 minutes looks good. Not so bad, right? I legit said this is gonna be the hardest thing we're gonna do all year. You okay with it so far? But I'm gonna warn you, this is not hard. Yes. Zero. So that's a good point. If you don't put the zero, what's it mean? You can either leave it blank or put them so there's no confusion. Either answer would have been fine. Same here, you can either put the 1 or 2 zeros or no zeros. It didn't really matter. Like I said, that's the start of the hardest thing. But if you don't understand that, I'm going to need you to make sure you understand it soon because you can't do what we're going to do tomorrow without doing this. Now we're going to go to the second chart. State how far a P wave and an S wave can travel in each of the times given below. How is this different than the last question? Okay, so we're given time and we want to measure distance. Basically, it's the reverse. So we're going to go to 4 minutes and 20 seconds. Okay, so we go to 4 minutes and 20 seconds. You go over till you hit the line. So we want the P wave first. And then you read down for how many kilometers that is. Okay, so it's just the reverse. It's saying it's traveling for 4 minutes and 20 seconds. How far away is the earthquake? That's what this is saying. So what'd you guys get for that first one? 4 minutes and 20 seconds. Going over to the P wave. Not sure where, so 4 minutes and 20 seconds. Go over till you hit the line. We're one line past 2,000. So remember those go up by 200s. That's 2,200. And then you do the same thing for the S. You do have to be careful that you didn't do the S first because the S you hit that first. Now, where is that line that for the S? It's not on the 1,000. It's not on the 1,200. Well, 1,100. And yes, you do have to estimate that. And this is where it was a little trickier to see that on. It's not trickier. It's clear as day. Never mind. Go ahead and do 3 more again. So you affected this. Don't. Yeah, it's not. But I don't know if it's going to do it. Yeah, so 200 kilometers is the option. Yeah, that's a lot. No, not for this, not that much. Yeah, that's why you have to take this next one. Hold on, you guys got this. Jonah had a perfect example. He said, well, I wasn't that far off. And he was only 2,000 kilometers off. And that's what a lot of you are going to say. Because it's legit. He was off by one line. It doesn't look like that much. 200 kilometers is from here to Syracuse, though. So when you think of it that way, is it off by a lot? Yeah. So you do have to be careful. And I know, Jonah, it's a pain in the butt, especially when you're using that little one, the not blown up one. It is hard to see, but you will have to take your time. Now, one thing I will say to help make life easier, if you've noticed on a few of these, I've actually been drawing on them. So for that 12-minute one, you might actually want, because he was trying to follow it along kind of like this, or kind of with your eyes. Your eyes are going to drift on this, especially when you're using that smaller copy. Your eyes kind of get bugged out with this. It's okay to actually write on your reference table and see that the 12 minutes hit at the 8,800 line. If you write on this and it gets too messy, I'll give you another page. It's not a big deal. I don't have to print you up a whole new reference table. I can just print you up a new page 11. So do whatever you got to do to be as accurate as you possibly can. Because like I said, yes, for this answer, 9,000 would have been okay. But when you go on and do the next steps that we're going to learn over the next few days, being off by 200 kilometers is going to be a big deal. So there I got 8,800 and then 3,700, 3,500 and 1,700. So then you might be asking yourself, well, like, how much is it okay to be off by? I would say to aim to be off by no more than 100. 200's okay, but you got to aim for being off by no more than 100. All right, and then for the last one I asked you to do, I got 5,200 and 2,400. So still not the hardest thing you've done all year though, right? Okay, good, because I still think it's the hardest thing you've done all year. Okay, good. So like I said, I try to break it down into useful, easy chunks. The next step is where it's going to start to get a little weird. So some of you I noticed have been trying to go ahead, and I'm sure you could figure this out. But if you do it my way, just trust me, I've been doing this long enough. My way is easier than doing math. So here's what the next step is. So those first ones just said, what is the travel time? Or how far can the wave travel in this amount of time? Now I'm going to change it up, and it says determining the arrival time difference between the P and the S wave. What does that mean? Any idea? You want to give it a whirl? Okay, similar. So Here's how I'm gonna relate it to real life. Let's go back to Angel's ride to work. It says determine the arrival time difference between the P and the S wave. So you hear difference, so you know there's gonna be subtracting. Again, I'm sure a few of you figured that out, and you can do it by subtracting. I don't recommend it. So this means, all right, so two people left Angel's house at the exact same time, one in a school bus, one in a car. The car, the P wave, gets here at 7:10. The S wave, the school bus, gets here at 7:30. I want to know the arrival time difference. So 20, just subtract. So now we're saying, okay, the P wave gets here at this time, the S wave gets there at that time. What's the difference? And yes, you can subtract, but there is an easier way. Here is the method I want you to use. We're going to start, see if you notice there's 4 steps. The first step is to find the distance at the bottom of the chart. So write that in for step 1. Find the distance on the bottom of the chart. Step 2. Place your scrap paper vertically, which means up and down. You don't have to write the up and down part if you're confident you know what vertical means. So place the scrap paper vertically for that distance. Step 3. Where do I go to steps 1 and 2? Step 3, mark the scrap paper where the P and S waves touch it. Step 4 is going to sound weird, and it is actually a little bit longer. You'll notice I gave you an extra line to write it. So write this, and then I'll explain what it means. It says, move the scrap paper to the left side of the chart. Place the mark for the P wave on the 0 and read the time using the S wave. Like I said, that one might sound a little weird until you give it a whirl. So when you're done writing, we're going to go try the first one in the notes or in the packet. So again, I provided you with these little strips of scrap paper. There's nothing fancy about my scrap paper. You can use the edge of any piece of paper. Don't pack up. We're going to do this one. So we're going to go to the notes. And the first example in the packet is for 8,000 kilometers. So we're going to walk through the steps. It says to find the distance on the x-axis. So you legit point to the 8. That's step 1. Step 2 is to take your scrap paper and place it vertically for that distance. So I'm at the 8,000 and I'm putting my scrap paper straight up and down for 8,000. So I just have it lined up with the 8,000 line. So everybody do this. You can use the big one or the small one. It doesn't matter. Then step 3 says to mark the scrap paper where the P and the S waves touch it. So here's the P wave. So I'm going to put a little mark on my scrap paper. Here's the S wave. I am going to go ahead and label those P and S waves. So I just on my scrap paper, put a little mark where the P wave and then where the S wave touches it. Now, because I've done this before, I recommend doing it. And those of you who are left-handed, I'm sorry. So you put the scrap paper to the right of the line and make your marks on the left edge of the scrap paper. It's going to make your life easier in this next step. Step 4 does say to take your paper, says to move the scrap paper to the left side of the chart. Put the mark for the P wave on the 0. So I'm lining up my P wave with 0. And it says read the time with the S wave. So now you can go right up. You got the P wave lined up perfectly with 0. And 9 minutes and 20 is good enough for this one. So 9 minutes and 20 seconds. So I just read, put the P on a 0 and read where the S wave line hits, right at that first line after. 9 minutes and 20 seconds. I would like you guys to do this side for homework. So you have 1, 2, 3, 4 more for homework. Just the one on the bottom there. Have a good day.